All right, today we're going to talk about a super material that's becoming absolutely essential for the future of aerospace, defense, and some really high-tech industries. It's called zirconium boride, and believe me, it thrives where most materials just give up.
So let's just jump right in with a question. Think about this for a second. What kind of material can actually survive the insane physics of hypersonic flight? We're talking traveling at more than 5 times the speed of sound.
I mean, just look at this simulation. At those kinds of speeds, the friction with the air creates an unbelievable amount of heat. We are talking temperatures on the nose cone and leading edges that can blast past 2,500 degrees Celsius. Most materials would just, poof, vaporize.
Well, the answer is this incredible material, zirconium boride. It's what's known as an ultra-high-temperature ceramic, and its superstar quality is its melting point. Get this, over 3,200 degrees Celsius. It is literally built for the most extreme conditions you can dream up. So, what's the secret sauce here? What makes this stuff so special? Well, let's break down the properties that make it a true material for the extremes.
Okay, so the real magic of zirconium boride is this crazy combination of properties. It's got the insane hardness of a ceramic, right? But then it also has the kind of thermal and electrical conductivity you'd normally expect from a metal. And that mix, that's what makes it a genuine supermaterial.
So, you can imagine, with a profile like that, this stuff is incredibly valuable. So how valuable are we talking? Let's get into the numbers and see what the market really looks like.
Let's rewind a bit to 2020. Even back then, the global market for zirconium boride was already sitting at a cool $74 million.
Now jump to today, 2025, and you see some serious growth. That market is now estimated to be worth $119 million.
And this thing is not slowing down. Forecasts are projecting it's going to keep climbing, hitting a pretty impressive $165 million by 2030.
In this chart right here, it really tells the whole story. You can see that powerful upward curve. What's really interesting, though, is you can almost see 2 different phases. First, there's a super aggressive growth spurt, a 10.1% compound annual growth rate leading up to this year. Then it's expected to settle into a really strong, steady 6.9% growth all the way through 2030.
All right, so we know the market is booming, but where in the world is all this action happening? Let's take a look at the global snapshot and see who's driving the demand.
Okay, so when you first look at this map, it seems pretty straightforward, right? North America and Europe are the big players here. They're totally dominating the market in terms of value right now. But that is not the whole picture.
Right, and this is where it gets really interesting. Yeah, North America is the leader with over 44% of the market, driven by their huge aerospace and defense industries. But the real headline for the future, you gotta look at the growth rate. Check out the Asia-Pacific region. It's growing at a jaw-dropping 8.46%. That's the fastest of any region. And it tells you there is a serious global race heating up in this kind of high-end technology.
So all this growth, all this demand, what is actually using this stuff? What are the key applications that are driving this entire market forward?
Well, this chart pretty much says it all. The demand is unbelievably focused. I mean, look at that. Just one application, ultra-high temperature ceramics, is responsible for a whopping 92.5% of the total volume. It's wild.
So what are we really talking about here? We're talking about the absolute most demanding, most extreme applications you can possibly think of. Things like the very tips and leading edges of hypersonic vehicles, the liners inside rocket nozzles, and the shields on spacecraft that have to survive re-entry. These are places where materials get pushed to their absolute breaking point.
So with a market this specialized and this high stakes, who are the companies actually producing this super material? Let's pull back the curtain on the key players.
And the first thing you need to know is this is not a market with tons of little players. Not at all. It is super concentrated. You're basically looking at an oligopoly, controlled by just a few big names.
In fact, as you can see right here, just 3 companies are really running the show globally. We're talking about Höganäs, Tribacher Industry, and Daiichi Kigenso.
Let's just break down those numbers for a second. Höganäs out of Sweden has almost 45% of the market. Then you've got Tribacher Industry from Austria with another 34%. And from Japan, Daiichi Kigenso holds about 18%. You add all that up, and just these 3 companies from Europe and Japan, they control over 94% of the entire market. Wow. So when we look to the future, what's going to keep pushing this market forward? Well, the number one driver, with a very high impact, is the development of hypersonic tech. No surprise there.
But right on its heels, you've got the boom in commercial space and the needs of advanced semiconductor manufacturing. The takeaway is pretty clear. A relentless push into faster, hotter, more extreme technologies is what's going to keep fueling the demand for this material.
And that really leaves us with a big question, doesn't it? As we keep pushing the boundaries, further out into space, faster through our own atmosphere, is this once niche, super material about to become a fundamental building block for the next wave of innovation?
Now, if you want to get into all the nitty-gritty details behind this breakdown, the full research report is available from HDIN Research. All their contact info's right there on the screen. Thanks for joining me.